Section 6.7, Partial Fraction Decomposition. Part 1, Partial Fraction Decomposition with Distinct Linear Factors. Some background on what we're going to do. This would be the opposite of decomposition. If I want to write 2 over x plus 1 plus 3 over x minus 2 as a single rational expression, that means I need to find a common denominator and add the two fractions together. I'm just going to rewrite it here so I have room. So my common denominator would be x plus 1 times x minus 2. So I will multiply the first fraction by x minus 2 over x minus 2, and the second fraction by x plus 1 over x plus 1. So I've multiplied both fractions by a version of 1. Anything over itself is 1. And then if I multiply here, I have 2 times x minus 2 plus 3 times x plus 1 over that common denominator. And I can simplify my numerator. I have 2x minus 4 plus 3x plus 1 over x minus 2 times x plus 1, which is 5x minus 1 over x minus 2 times x plus 1. So the goal of this section is the opposite of what we just did. I'm going to start with this final answer, the 5x minus 1 over x minus 2 times x plus 1, and break it down into these two partial fractions. So I'm going to take one rational expression and break it into separate fractions. So to do that, there are 4 different cases. The first one will be where the denominator has non-repeated linear factors. So in our rational expression, the denominator can be factored into linear factors, and none of those factors are repeated. So if I have p of x divided by q of x as my rational function, then each factor of that denominator, if the factors are non-repeated and all linear, will be a denominator in one of the partial fractions, and the numerators will be constants. So for example, so you can see what that means, if I have 7x plus 9 over x plus 5 times 2x minus 3, I have 2 factors in the denominator, and both of those are linear factors and they're separate. So I can put each of those in a partial fraction, in a denominator of one of the partial fractions, and then the numerators will be constants. I'll just call those a and b. And then my goal will be to find the a and b that make that equals true, that the left side now is equal to the right side. Let's try that. We're going to use 2 different methods. This first method will be equating like terms, and to do that, we'll solve a simple system of equations. So I've set up the partial fraction decomposition like we did on the last slide. Now I need to clear the fractions. Your first step will always be to clear the fractions. So I'm going to multiply both sides of the equation by that common denominator, which is x plus 5 times 2x minus 3. I'm going to multiply the other side also by that common denominator. So I'm also multiplying this side by x plus 5 times 2x minus 3. So on the left side, both of these factors cancel, and I have 7x plus 9. On the right side, when I distribute to both fractions, the fraction that has the a, the x plus 5 cancels, so I'm left with 2x minus 3. And the fraction with the b, the 2x minus 3 cancels, and I'm left with x plus 5. So I've cleared the fractions. I no longer have any fractions I have to work with. Now I need to find a and b. To do that, I'm going to distribute through on the right side and then collect like terms. So I have 7x plus 9 equals 2ax minus 3a plus bx plus 5b. Then I will get everything, all of the terms with an x together. So I have 2ax plus bx. And then the constant terms, so negative 3a plus 5b. So I have the x's. I'm going to factor out an x out of that first part. I have 2a plus b. And then my constant is negative 3a plus 5b. Now look on the left side. I know the coefficient of the x is 7. So the right side, in order for this to be true, this equal sign, I'm saying the left is equal to the right side, then this coefficient of the x also has to be 7. So 7 equals 2a plus b. And then the constant on the left side is 9, and the constant on the right side is negative 3a plus 5b. So 9 equals negative 3a plus 5b. And that's what I mean by equating like terms. Whatever the coefficient of the term on the left, so the coefficient of the x is 7, which means the coefficient on the right side of the equal sign also has to be equal 7. And if the constant on the left side is 9, the constant on the right side also has to be 9. Now this is the system of equations I need to solve. It's not a particularly difficult one. I'm going to multiply that top equation by negative 5 to eliminate the b. So if I do that, I have negative 35 equals negative 10a minus 5b. And then I'll add these two together. And I'll get negative 26 equals negative 13a and 0b. Divide both sides by negative 13, and I get a equals 2. So I know a equals 2. Now I need to find b. I'll go ahead and plug that in to say this equation. So 7 equals 2 times a, but a is 2, plus b. Subtract 4 from both sides, and I get 3 is b. So I found the a and b for this partial fraction decomposition. So my answer is 2 over x plus 5, because a is 2, plus 3 over 2x minus 3. And that is equal to the original rational expression. The other method is known as the Heaviside method, or we can talk about it as by substituting convenient x values. To do this, we're going to start the same as we did before by clearing the fractions. So when we cleared the fractions, we got 7x plus 9 equals a times 2x minus 3 plus b times x plus 5. Then from here, I'm going to pick a convenient value of x to substitute in for all my x's. Now this equal sign, I want the left side to be equal to the right side no matter what x is. So I'm just going to pick a value for x. And I'm going to start by picking x equals negative 5. The reason why is because that will make this term, b times x plus 5, equal to 0. And if I can get rid of that term, so there's no more b, I'll have an easier time solving for a. So I'm going to let all my x's on both sides of the equal sign be negative 5. 7 times negative 5 plus 9 equals a times 2 times negative 5 minus 3 plus b times negative 5 plus 5. Now negative 5 plus 5 is 0, b times 0 is 0, so that part is just plus 0. So on the left side, I have negative 35 plus 9 equals a times negative 10 minus 3 is negative 13. So I have negative 26 equals negative 13a. Divide both sides by negative 13, and I get a equals 2, which is what I had before. So I have 2 over x plus 5 plus something over 2x minus 3. Now to find b, I'm going to go back to this equation that I'm putting a star by. Every time I need to find a new variable, I'll go back to there. And I'm going to now set x equal to 3/2. And I got that because when 2x minus 3 equals 0, then x has to be 3/2. So I have 7 times 3/2 plus 9 equals a times 0 plus b times 3/2 plus 5. And now I can solve for b. So 7 times 3/2 is 21/2, and 9 is 18/2. And on the right side, I have b times 3/2 plus 10/2. And 21 plus 18 would be 39. So I have 39/2 equals 13/2 times b. Multiply both sides by 2/13, and I get 39 over 13 equals b, which is 3. And that is the same answer I got before. So now this is the partial fraction decomposition, same as we had before, just using a different method. You can pick which method you want to do. Sometimes one might seem easier, sometimes the other might seem easier, sometimes you might use a combination. It doesn't matter. Either method is totally acceptable.